Hello everyone. Today we are going to discuss about the box culvert design and analysis process. So generally these box culverts means the culverts are mainly used for the purpose of the drainage or the water passageway or vehicle passageway. For the passageways it will be used. So these are generally used at the side at which the below the train tracks, below the highways, below the flyovers, etc. So mainly use of this is that it is used as a passageways for many things to pass. So these are built in, firstly these are built in STAAD Pro VI software. So let us open this and let us click on and let us create the project. So let us go for here now new project, click on space and let the structure be named as box culvert. Okay, box culvert, it has been created. Next we will be click on let the length units be in meters and force units be in kilometers. Click on next, add beam, click on finish, wait till it's loaded. So in this way it has been created. Then now we have to give the box culverts. So let us go for this edit and let us select this exit plane. Okay, click on OK. Now we have to create the box culvert. So first of all let us create the box. So in this way the top view of this culvert will be drawn. Then let us off this one and let us select these beams and create a box here. So let us click on this floor one. Then next go to transitional and put in y direction. The number of steps be 1 and the default spacing be 3 meters and click on link steps. Then click on OK. So in this way the box culvert will be created. Okay, next we have to join these nodes. Let us see what is the distance. First of all let us since the distance are same we have to join these ones. So let us go for this add beam command, click on here and here, from here to here, from here to here, here to here. So in this way the box color will be designed. So after this we have to create the geometry, we have to produce the mesh to the 4 sides of these plates. So we then go to click command, add mesh. Okay, next we have to add the mesh. So first of all let us add the mesh here. quadrilateral one, click on OK, click on apply. So the mesh has been created. Okay, now let us add mesh here also. Sorry. Let us create this first mesh here. Let's go for the quadrilateral one, then click on apply, then click on. Next we have to add here and here. So go from here to quadrilateral, click on OK, click on apply. So the mesh has been applied. So let us save this one first. So we have to click on quadrilateral, click on OK, click on apply. So it has been created. Next we have to create mesh here also, here. So we have to create this one. So first of all, let us create a surface here. So then let us go for this downward view and go for here add surface. So here the surface is there. Okay, here you could see the surface has been added. Now we have to add here a mesh here and here. So let us add this one. So we have to provide here the mesh to these walls which are present. Now you can see for these 4 walls we have to provide the mesh. So then let us go for here, then click on top. Now here we have to give this mesh this ones, click on OK, then it's done. Then we will be going from here to click on OK, it has been created. Here now you can see here, you can also see this in 3D rendering view. So here you can clearly see this one, the water will be passed from here. So in this way the box culvert will be created. Here you can see, and let us click on cancel. So it has been completed. Let us see whether the surface is added or not. Here you can see the surface is added. Click on cancel. Okay, next after the geometry we will be going for the general. In general, first of all let us select all the members which are present and we have to delete it. Then after that click on all of this one, click on delete, click on OK. So all the beams will be deleted. So here all the beams are deleted. Now let us, if you want you can select, there are no beams. So in this we have to specify the properties. So first of all, for properties go to define, not define, we have to provide the plate thickness to every one of the plate. then go to thickness, then for this one provide thickness of 0.23 for everything, then click on add. Then next you have to provide the surface thickness also, it will be 0.23, then click on add, click on close. Okay, we have to assign this one, so click on plate thickness, click on assign to view, click on assign, click on yes. Okay, all the plates have been assigned with this plate thickness. Next we will be going for the surface thickness, go to assign to view, click on assign, click on yes. So it has been assigned. Here you can see this one. Okay, so after assigning this we have to give the supports. Okay, after giving the property we will be going for the supports. In supports we have to provide the supports here to here, here to here and here. Okay, so first of all let us go in this top view, let us select this node. Okay, select this node and select this node. Also see this in top view. Okay, we have to select this. We selected this 3 nodes, then in top view we have selected this one, sorry, in the front view. Then we will be going for this right side view here, select this one also, and let us see it has been selected. So all the 4 nodes here, here, okay, so all these are selected. Then we have to create the supports. Click on add, click on supports, sorry, we have to add this one. So click on the supports for which we have to place it on. So in this way we have to select all the supports where at which we want to give the supports. Click on assign, click on yes. So here you can see clearly the supports have been placed. Okay, you can see this one. So all the supports have been placed. Next let us go for the loads and definitions. In loads and definitions we will be acting only the dead load and the live load, which will be acting by the hydrostatic pressure. Okay, so let us go for this load case details. Click on add, then go for this dead load, it will be named as DL. Click on add, and let us go for this live load, click on add, click on close. Okay, for dead load click on add, go for this sulfate, click on add, click on close. Next we will be going for the live load. In live load we will be going for this plate load because of the pressure. So we will be going for this hydrostatic pressure because the water will be passing. We are assuming that the water will be passed from the culvert, and go for the selected plates, then selecting the plates. Then we have to keep for every one of the plates. Okay, then let us go and select all of these plates. All of the plates have been selected. Sorry, the live load is acting only on this box culvert. Then let us go in this view here. So in this only the live load will be acting. Okay, click on done. The live load will be acting in y direction, let the hydrostatic force be minus 30 kilonewtons, then click on add on close. So here all of this has been done. Okay, next let us save this one. Since there is also a surface, then we have to provide the surface load also, that means the load on the surface. Then we will be going for this load gauge details. Con add for surface loads, let us give this as non-load, then let us give it as surface downwards. Click on add, click on close. Okay, next for providing this, click on add, go for the surface loads, then pressure on the full surface, let it be named as minus 40 kilonewtons. It is in local GY direction. Click on add, click on close. Okay, it's been done. Then let us give it and assign, let us assign yes. So it has been assigned. Here you can clearly see this, it has been done. Okay, next we will be going for, let us assign the sulfate. Click on assign to it, click on assign yes. Okay, sulfate has been assigned. Okay, so here the live load will be seeing in this way, clearly see here. So how the live load is acting. So the live load is acting in this way. And so here you can see here. So in this way the live load will be acting. From sideways also we can see here. Okay. In this way we will be seeing this one. Sulfate and is acting into the overall. Okay. Next we will be going for the material. For material we will be using only concrete, so click on concrete, click on assign to you, click on assign, click on yes. Okay, it has been assigned. Okay, next we will be analyzing the structure, then go for the perform analysis and click on add, click on close. Okay, we are going to perform the analysis. Click on analyze, click on run analysis, click on save. Let us wait for the errors to appear. So here you can see that we are getting 0 errors, 0 warnings and 0 notes. So our structure has been designed by, analyzed by completely. So click on done, click on apply, click on OK. Okay, now here you can see it one. So this is the dead load is acting, this is the surface load will be acting, this is shear force in x direction, moment in x direction. First of all, okay, let us go for this plate stresses. Here you can see for surface load, here the pressure acting is more. At the center the pressure is acting more. For dead load, the supports it is acting more. Then for live load, it is acting at these ends, but not that much. So we will be going for the animation, click on deflection, click on apply and then click on OK. For live load we can see in these two members the deflection will be there. For dead load, so for dead load there is no such deflection. For surface load, here you can see this. For surface load also these members are getting deflected. So let us go for this modeling view. Here we can go for the design part. In design part we have to provide the load. Then let us go and select the concrete. Then after selecting IS456, then go to select parameters, then deselect all of this, then go for the compressive strength of the concrete, click on copy here. On main shear reinforcement, click on yes, click on sectional reinforcement, click on yes, click on OK. So define parameters, we will be defining the parameters as 30,000, click on add. For main reinforcement, let it be named as 5 lakhs, click on add. For sectional reinforcement, it will be named as click on add, click on close. Then go after defining the parameters, we will be going for the commands here. Then go to design of the slab element, click on add, go to takeoff, click on add, click on close. Okay, all of it has been done. Then go for the FC main, then go to assign to view, click on assign, click on yes. Okay, has been assigned. Go to F5 main, click on assign to view, click on assign, click on yes. The main reinforcement is assigned. For sectional reinforcement, we click on assign to view, click on assign, click on yes. Since it is not assigning, let us delete this command. So next we will be going for the design element, and click on assign to view, click on assign, click on yes. So it has been assigned. Let us go for the analysis option. Here we have to go for the perform analysis, click on add, click on close. Perform analysis has been given. Now we have to analyze the structure. Then we will be going for the analysis, then run analysis. Let us save this one and let us wait for the design analysis of the building, of the culvert, box culvert. So here you can see that we are getting 0 errors, so our structure has been successfully designed. So click on done. Here you can see completely here movement in any direction, creating the go for the dead load, live load. Okay, go for here the plates, go for the maximum absolute, click on apply, click on okay. Here you can see clearly due to surface loads it is acting this one, due to live load it is acting on these sides, and due to dead load it is only acting at the supports. Then in animation you can go for the deflection, click on apply, click on OK. Can you see the deflection? For live load you can getting the deflection here. Here surface load we are getting the deflection here. In this we will be getting the deflection in this way. So let us view this in 3D rendering view. So let us go for this 3D rendered view. So here you can see this one. Here you can clearly see the box culvert, how it is designed. Here the surface thickness is given, here the plate thickness is given. You can see here clearly. Okay. Here you could see here, you can see here clearly. Here you can clearly see this one. Okay. So then we will be going for the foundation design. Then let us click on foundation design. Then let us include all the available load cases and click on include all. Then let us run this STAAD foundation so that the foundation will be provided for this box culvert. Then after this let us go for this loads and factors and go to generate load combination. Let us choose the Indian standard and we have to generate the load combinations. Load combination has been generated. Then let us go for this ultimate load combination. Then the load combination has been generated. Click on OK, click on cancel. Next we will be going for this job setup. Let us create a new job. Let the job name be named as culvert. Let it be named as India. It is SI standard. So let us import all the loads. Then click on create job. After creating a job we will be going for the isolated footing job, and we will be going for the this is the concrete and rebar details. Here you can see that unit weight of the concrete, that is minimum spacing and the maximum spacing, strength of the concrete, Daily strength of the steel is taken as 415, minimum bar size is 6 and maximum bar size is 30. Okay, click on cover and soil. Here you can see the soil conditions. It is only taken in the drained conditions. This is the footing geometry. Minimum length, width and thickness is provided, etc. will be provided in here. So then let us go for the sliding and overturning. The quotient of friction is taken as 0.5. Factor of safety against sliding is 1.5, against overturning is 1.5. Let us go for this design. Let us analyze this design. So let us wait till the design progress report will be completed. So here you can see clearly see this. So the number of footings are 8. So here the footings are taken as 8. This is the bottom reinforcement. This is the bottom reinforcement for moments. So top reinforcement. This is the structure at which we will be doing this one. So we will be going for detail and schedule drawing. So here you can see here. You can see this. 4.30 meters is the length and pedestal dimensions and 50 mm column type. Okay. Now let us go to the GA drawing sheet. Here these are the 4 footings we will be providing here. So here you can clearly see the dimensions of the footings. So calculation sheet is this one. So there are no graph sheet. So detailed geometry. So okay, in this way it will be assigned. Okay, then let us click on cancel. Let us save it firstly. After saving this will be appearing. Let us see this in a 3D rendered view. So here you can see here. You can hear clearly, you can see this one, box culvert. In this way the box culverts will be designed. Okay, so then let's go for this modeling. So in this way it will be designed and analyzed. So thank you everyone, thank you. The class has been completed.